The following is the video solution from JSDT Solutions. Question 9 says, an industrial chemical is stored in rectangular containers with a square base. Okay, so this is one model of the container. Okay, and the square base has X centimeters, X as the side and the other side of the base. The height of each container is H centimeters as shown on the figure below. The volume of each container is 2,160,000 centimeters cubed. And 9.1 says, determine the height of the containers in terms of X. Okay, so they've given us the volume. And to determine the height, we can think about how volume is calculated because it will include the height. So volume is equal to the area of the base, and the base is a square, so that's going to be side times side, so x times x, which is x squared, multiplied by the height. Okay, it's always area of the base. You can find the area of the base, and then you multiply it by the height, you will get the entire volume of the shape. Now we already have the volume. It's 2,160,000. So 2,160,000 is equal to, we don't have this, we're just trying to find h, okay, multiplied by h. And so to get h on its own, so it can be in terms of x, we can divide both hand sides of this equation by x squared, okay, and that will get h on its own. So therefore, the height is equal to 2,160,000 divided by x squared. And that is our answer for the first question. Moving on to the next question. Question 9.2 says, for safety reasons, during the transportation of the containers, a triple layer of material is needed at the base of the container. Okay, so we just need to see what this will look like. They say ignore the thickness of the material, gladly, because that would complicate things. And they want us to show that the total surface area of the material used for the container is given by this. Okay, so let's just take this image quick and then see what this will look like. Okay, so this is our container, and all they're saying is they're going to add a triple layer of material, okay, at the base. So this is what the base would have looked like. Normally, we would just need a layer, okay, of material because they're going to cover it with something. Clearly, that's what they're saying. And if we're going to put a triple layer at the base, it just means this base should have 3 of whatever it used to have. So it used to just be x by x, and now it's going to have another layer and then another layer as well. So we're now going to also have to account for the material that will be used for those 2 added layers. So including this one, it's now 3 layers at the base. Now, I don't really know what material they're using. Maybe they're painting it, okay? But if we're adding some sort of material, okay, around this object, around this, and they're telling us show that the surface area is this, we're just trying to find the surface area of this entire shape. So let's look at the areas that will be covered. We're going to cover the top, which looks exactly like the bottom. It's also just x by x. We're going to cover the bottom, so it's that first base, and then the 2 other bases as well. So we have a total of how many of these squares, these x by x squares. We have this one on top, 1. We have the first base on the bottom that we already had, that was 2. So this one is 2. Then we have these 2 added ones since we must have a triple layer, okay, base. So that is 3 and 4. So we just know we have 4 of these shapes that we need to consider. And then with these shapes that we have here, these rectangles. Okay, so we have that first rectangle and it's an x by h rectangle. So that's 1. And then we have the one on the side, 2, the one at the back, 3, and the one on this side, 4. So that's what we're just putting together. So we're finding the areas of each of this and accounting for how many of those shapes that we have. Okay, so the total surface area would be equal to, we will say, let's start with those bases. We have 4 of them. So it's 4 multiplied by x times x, which we know will be x squared. So that's all those bases that we have. And the top, of course. And then plus, and then these blue ones, these rectangles, we have 4 of those as well. So that's going to be 4. And the area of each of it, its length is h and the width is x. So that is h multiplied by x. So let's just substitute because we already have a value for h. This is in terms of x. So that's all we have to do. So we can finally call this a of x is equal to, and this will be 4x squared. And then, well, you see, that's not 2 terms, it's 1 term. It's going to be xh. So let's just rewrite this as, because we know we're substituting in place of h, we can just call this 4x multiplied by, and then the h is this number, okay, 2 million, and then that, and we just have to simplify this. So therefore, a of x is equal to 4x squared. And when multiplying, you see, we're adding to this. So this is a term on its own. And so we're multiplying these two values together, meaning diagonally, do you see that we have a common factor of x? So that will cancel, x cancels here, and one of the x's cancel here. So 4 multiplied by that number, let's just get that. 4 times 2,160,000, and that is 8 million. Okay, so we're going to say that this is added by 8,640,000 over x. Okay, and then just see, is that what they have as well? Yes, okay, that is our area. And moving on to the next question. Question 9.3 says, we have to determine the dimensions of the container that will ensure that the minimum amount of material is used when making the container. So what we are seeing as the material is the total surface area, because that's what goes around this material. Okay, and we just found that the total surface area is this. Now we need to find the dimensions. If they're saying dimensions, they don't just want the values of x, okay, because the x was those dimensions for the base and of course the top part of the shape. But this will also include the height. So the dimensions just means you need to find x and h as well. Okay, so find the values of x and h that will ensure that the minimum amount of material, we already know that the material is now referring to the surface area. So find the values of x and h for which the area, this will be a minimum. We can see now this is a maximum and minimum problem. So we're going to take the area that we have and we're going to find the x value at which this is going to be a minimum. You're trying to find a minimum or maximum value. Okay, works like with a turning point. When you're trying to find the minimum or the x value at least at which this is a minimum, remember that at this point, this is where the gradient is equal to 0. Okay, it's no longer decreasing or increasing. So that's what we're going to do here. Let's find the gradient of this function. Now, do you see that to find the gradient or to derive this function, we have to move this x up to the numerator because we can't derive like this. So we'll rewrite our function. This is equal to 4x squared, and we're going to say plus 8,640,000, and now it's x raised to the power of, its exponent was 1, so it becomes -1. And now we're ready to derive. So this is a prime of x is equal to 4 times 2 is 8, so x raised to the power of 2 minus 1 is 1, and you don't have to rewrite that. Coefficient times exponent, that is -8,640,000, and then x raised to the power of exponent minus 1 is -2. Great. And now we can make the gradient equal to 0, the derivative equal to 0, so we can find that minimum value. So this is 8x, and then we have minus 8,640,000. And I'm just going to go ahead and rewrite this so that its exponent is positive. So it's currently in the numerator. We move it to the denominator. And so it's x squared. Okay, this is negative. We can just transpose it to make it positive. So it's now positive 8,640,000 all over x squared is equal to 8x. And now just cross multiply. X squared multiplied by 8x is 8x cubed is equal to 8 million. So this has a denominator of 1, so they multiply. 8,640,000. And now we can solve. So just get rid of the 8 by dividing both hand sides of this equation by 8. Let's see what that gives us. We already had this number, so divided by 8, okay? And so x cubed is equal to 1,080,000. And then we can cube root both hand sides of this equation. So cube root, this doesn't work like square root. You don't have to consider the positive or negative solution. So x is simply equal to, we'll take this, and we're going to cube root that answer that we got. You just make it simpler. Okay, now just to ensure that this is correct, I'm just going to find the cube root like this. So the cube root of 1,080,000. Okay, and you can see what it gives us. It gives us 60, the cube root of 5, okay? And in decimal form, well, you can't leave it like this because you have to round out to 2 decimal places either ways. So that is 102 point, and that is going to round up, making that a 6. So 0.60. And then with this, we can find h. So you need to find the dimensions, so x and h. So how do we find h? You can just use the equation for h. So take this and substitute in place of x, and we'll find this. At this point, you can decide to either use this rounded off answer, or you could use that. I would actually just use the more accurate one and then just round both answers off to 2 decimal places. Okay, so that goes all over 60 cube root 5 all squared, and let's see what we get. Okay, so the answer of h there is 205 point, and that 7 is going to round that up, and then it goes to that one, which becomes a 2, so 0.20. And they're both in, what were these in? Centimeters, because this volume was in centimeters cubed. Okay, as we saw in the first question. So we can finally say that is centimeters, and that is centimeters, and that is our answer. Okay, so those would be the dimensions if a minimum area, okay, were to be used. Okay, so those are our answers for question 9, and that is it for question 9.